Thakur Vidya Mandir High School and Junior College welcomes all the 12th standard computer science students. Today we are going to start with Unit 3, Introduction to X86 Family. We can also call it as Introduction to the Intel Family or else Advanced Microprocessors. We are only going to learn the introduction part. Firstly, let us understand the members of X86 family. They are 8086, 8088, 80186, 80286, 80386, 80486 and 80586. Now in this 8086, 8088, 80186 almost have the same features. Now why do we have the name X86 family? Let's learn this concept from the evolution of microprocessor that we have already studied in Unit 1. We know when the generation went on, the word length was doubled, right? So the first general purpose microprocessor was 8085. Then invented the 16-bit family, that was 8086. Then invented the 32-bit family, that was 80386 and 80486. Then 64-bit, which was 80586, which is 64-bit. So each and every time the word length is double. So we are extending the word length. So X stands for extended, first thing. Now what was the need to invent the advanced microprocessor? We have learned in the evolution that along with Intel, many more processors came into role that was manufactured by other companions like Motorola, Toshiba, Intershale, Hewlett-Packard, and so on. So, in order to give them a tough competition, the advanced microprocessors was invented by the x86 family. Now, let us learn about each and every processor in detail. But today we are only going to learn in detail about the 8086 microprocessor because after the invention of the advanced technology, that is the advanced microprocessor, 8086 was the first general 16-bit microprocessor to be manufactured. Before going ahead and learning the features of 8086 and its advantages, let us understand first what are the demerits of it. The first demerit is the opcode. As we know here in 8085 there is a problem of opcode. So what will happen that whenever you are writing a program, the program will be first converted into opcode with the help of the opcode sheet and then we update it in the microprocessor. So what's going to happen here when I'm updating via the opcode? If one opcode goes wrong, the entire program we have to check again. The entire program will not run. Second thing, it will not show exactly where is the error. So this all becomes the disadvantages. No instruction for multiplication and division. As we know, we are going to consider the repeated addition as multiplication and the repeated subtraction as division. So if I am having a clear-cut instruction, the length of the program or we can say the size of the program might have reduced. So here, since we are going to do repeated addition, the program becomes little lengthy. It doesn't perform any trigonometric functions like sine, cot, cos, etc. It doesn't perform any trigonometric functions. Memory accessing capacity is just 64 KB. So it has limited memory accessing capacity and lastly it is an 8-bit microprocessor. So we are only going to do 8-bit operation at a time and if I'm going to do 16-bit or 32 operation at a time, at that time the program becomes lengthy. So this all comes under the demerits of 8085 microprocessor. Now let's learn the advanced features of x86 family. As we have said, what are the demerits of 8085 become the merits of advanced features of x86 family. No opcode, we can extend the memory. It has a very powerful computing set. It is a powerful computing device too. It supports math coprocessor, that is it can perform trigonometric functions and so on. So what are the features? Let us learn here. First, capable of performing various computing functions and making decision to change the sequence of program execution. It has a very strong, powerful instruction set due to which it can execute any program plus the program will be executed in a sequence way and it can take its own decision. That is, it can even perform multiplication and division. We have separate instruction. It's a very powerful computing device. It supports coprocessor. Now, When it supports a coprocessor, the coprocessor can be either external or internal. What is a coprocessor? It is a device which is used to perform trigonometric functions. We can also call it as a math coprocessor. So internally means inbuilt inside the IC, it will be inbuilt. Externally means, let us take an example of 8086. 8086 doesn't perform trigonometric functions, but along with 8086, if I'm introducing an IC 8087, 8087 will help 8086 to perform trigonometric functions. So again I'm saying 8087 will help 8086 to perform trigonometric functions. This is how a math coprocessor is supported externally as well as internally. Operating system. It uses a multi-user and a multitasking operating system. Now, what is a multi-user and a multitasking operating system? First, let us understand what is a multi-user. Multi-user means that is multi-user operating system enables two or more users to run programs simultaneously, while multiprocessing operating system supports two or more processors to run program at the same time. So multi-user means two or more user can run. Multitasking means the processor can run two or more programs at the same time. Microprocessor supports both multi-user and multitasking operating system. Next comes the virtual memory. So we know the virtual memory size is two or more times bigger than the real memory. The virtual memory is a temporary memory which is used for storing a large amount of data. So we can read the program, we can write the program in the virtual memory, but execution always takes place in the real memory. For that, we have to convert the virtual memory address into real memory address. Now, whenever we are working with the virtual memory, we know the entire program is broken down into small blocks. We call it as pages. Each and every page has its address which is present in the page table. So whenever we are going to run the program, a part of the that is program which is there in the virtual memory will be first converted into real memory mode. It will be copied and then converted and then it will be executed in the real memory. This is how the function of virtual memory. The simple thing, a virtual memory is a temporary memory which is used for storing a large amount of data. Already we have elaborated this in our 11th standard. Next comes the microprocessor includes special instructions and internal hardware which allows the programmer to write software without knowing how much memory is available. So the microprocessor includes special instructions and internal hardware which will be allowing the software to be written more. For example, let us take if we are working with the microprocessor of x86 family, if the internal memory gets full, automatically the external memory will be accessed without disturbing the user, that is without interrupting the user. We know if my phone memory gets full, automatically an interrupt will be given that phone memory is full or your SD card memory is full, delete some items. This type of problem will be not taking place in the x86 family. So once the internal memory get full, automatically the external memory will be accessed without the knowledge of the memory addressing capacity is more. So we know how we calculate the memory addressing capacity, that is 2 power the address bus width. The execution speed is more. It supports no opcode. So here, as I said, it supports no opcode. So what programming we are going to learn? Again, we are going to learn here the assembly level language program. Simply we call it as mnemonics. So what is going to happen here in the advanced feature, in the advanced x86 family? That is, the programming can be done in two ways, especially in 8086. The programming can be done in the kit which is available, as well as we can do the programming in our DOS, that is the disk operating system. Now, whenever we are doing the programming, we need not have to convert the mnemonics into opcode. Straight away, we can update the mnemonics so that we can execute it at a faster rate. First thing, and second thing, there is no error. So this all comes under the advanced features of x86 family. Now let's understand. So firstly, let us learn about the features of 8086. We know after the invention of the advanced processor, 8086 was the first microprocessor to get manufactured. 8086 architecture is almost similar to my 8088, which was also manufactured at the same time. It is a 16-bit processor. Address versus 20-bit and data versus 16-bit. So the memory accessing capacity will be 2 power 20, that is approximately equivalent to 1 MB. It is a 40-pin IC where the pins are arranged in DIP, that is dual internal package. Clock frequencies, it's going to range from 5 megahertz to 10 megahertz. 10 megahertz is the most common frequency of 8086. Operates in minimum and maximum mode. Now, what is the minimum and the maximum mode? Here in microprocessor 8086, there will be a separate set of pins, that is pin number from 24 to 31. This set of pin will be performing a type of function in minimum mode. The same set of pins will be performing some other function in the maximum mode. So, it operates in both minimum and the maximum mode. Address bus is multiplexed with the data bus to form multiplexed address slash data bus. So we know in order to reduce the number of pins, we are going to perform the operation of multiplexing. So here the 16-bit data bus is multiplexed with the 16-bit address bus, and here A16, A70, A18 and A19. These four address lines will be kept separate. 8086 internal architecture is similar to 8088 architecture. The only differ in external design. This we have already learned. Power and clock are identical to that of 8085 microprocessor. That is, it will be requiring plus 5 volt DC power supply. And here we are going to connect a crystal in order to provide proper clock for the operation. It supports external math coprocessor. As I said, that the 8086 will not perform trigonometric function. 8087 will help 8088 to perform 8086 to perform trigonometric function. Even the same is applicable to 8088. So it supports external math coprocessor. It has pipelined architecture. Now what is a pipelined architecture? In order to speed up the execution, there will be a few set of instructions will be prefetched and it will be kept ready for the execution so that the processing takes place at the faster rate. It has a 16-bit ALU and it operates with plus 5 volt DC power supply. So these are the features of X86 family. It is a 16-bit processor, address bus is 20-bit, data bus is 16-bit, memory accessing capacity is 1 MB, no opcode, it operates with plus 5 volt. It supports pipeline architecture, it supports external math coprocessor, and so on. Now let's learn the pin configuration. We are not going to elaborate the pin configuration. We are only going to learn the minimum and the maximum mode. You can see here from pin number 24 to 31, it will be working in the maximum mode. The operation will be QS1, QS0, S0 bar, S1 bar, S2 bar, lock bar, RQ bar slash GT1 bar, RQ bar slash GT0 bar. And here in the other hand for the minimum mode we have the operations. Now the minimum and the maximum mode will be selected with the pin 33. So we can see that it is written as MN slash MX bar. So when MN is 1, it is going to perform the operation of minimum mode. When it is 0, MX, that is maximum mode, becomes 1. So it is going to perform the operation of maximum mode. Let us differentiate 8085 and 8086. 8085, it is a 8-bit microprocessor, it is a 16-bit microprocessor. Here the data bus is 8-bit, the data bus is 16-bit, address bus is 16-bit and address bus is 20-bit. Memory accessing capacity, that is 2 power 16, almost we get 65,000, we round it off, that is 64 KB. Then here memory accessing capacity is 1 MB. It provides 8-bit registers like A, B, C, D, E, H and L and so on. It provides 16-bit registers like AX, BX, CX, DX and so on. So here in 8086, the 16-bit registers can be also used to perform 8-bit functions. The flag register is 8-bit and it has 5 active flags. Here the flag register is 16-bit and it has 9 active flags. Now here the 9 active flags is also further divided into control and status flags. It is operated in only one mode. It is operated in minimum and maximum mode. Do not support math coprocessor. It supports math coprocessor. Then it has opcode. Then 8086 doesn't have opcode. Along with that, we can say 8085 doesn't use a pipelined architecture and 8086 uses a pipelined architecture. We can add this point also. The memory accessing capacity is less. Here the memory accessing capacity is more, and so on. So these are the difference between 8085 and 8086. So in today's class, we have learned what was the need to invent advanced processor, what does X stands for, demerits of 8085, advanced features of X86 family, the features of 8086 microprocessor, as well as we have differentiated microprocessor 8085 and 8086. In the next class, we will about the block diagram of 8086 microprocessor. Thank you.